Okay, in this case, when we're implementing the code after testing, we okay we for example, when we in this case we want, for instance, we only want positive numbers. Okay, so we write a test that fails if a negative number is added. Okay, so when we want to implement our code, we write a validation that passes that test. Okay, so that's the next thing. When we implement our code, we ensure that the first variable is greater than zero. Sorry, the first variable, if the first variable and the second variable is lesser than zero, it returns an error. Okay, so we first thought about the test before we wrote the code. So the next thing, so it helps us write minimal and focused code. So we're not trying to write like a bulk code. Once our test has passed, that is enough. Okay, once our test has passed, so once we get our expected value, once we get our expected value for the test, that works for us. Then, so we, so the next thing that test-driven development does for us, it protects us against complicated designs. For example, it helps us write cleaner codes. If we're going to have if we're going to be testing like a long variable, like we're going to be testing so much, what we try to do is that we try to simplify how we write the code. So let me explain what we have here. For example, so we want to test our basic sum, and we want to test our basic sum, and we don't want it to return a negative number. So what we do, sorry. Okay, so we want to test the first one we want to test for like we don't want it to return a negative number, and the next one we don't want it to take a negative number in. So we write tests we write those tests first, and then we write our solutions. We write our functions to act as the solutions to those tests. So I'm going to talk about just a little benefits. So it helps, like I mentioned, it helps us focus on like writing minimal and functional codes. It helps us protect us against fanatic writings. For example, we can have multiple people on the team, and then people are writing fanatically. People want to over-engineer things, but that's not necessary if we have a set test, if we know what we are doing, and we just want it to give a required output. I don't know if you're all following. Right. So another thing is confidence in refactoring. So if I have a test and I've thought about my test and I want to refactor my code sometime, I know that it should still pass my test. So I can easily come back and refactor the code whenever I feel like, or anyone can like make the code a lot more better, but it should still pass the test. So like whenever someone builds a very large, for example, if you're building fast in the startup and you write enough tests, let's say you build a feature and somebody refactors something that breaks another function. Okay, let's say you made a new feature, but it breaks something else. Once I run that test and it fails, I know that something is wrong somewhere. Okay, so it helps us build faster. It helps us have confidence that, okay, I can go forward, I can build whatever I want to build. But when I come back, I know that, okay, when I run this test, I know if something is broken here, I just think this is where I need to fix. Okay, so I'll now be more specific. So this idea, basically, test-driven development can be used in every language. It's language agnostic. You can use it on your Python code, your JavaScript code, but that's the idea I would want to use going into testing in Go. Okay, that's like my main topic. So why do we really want to test, for example? Why do we want to avoid breaking, like I mentioned, we want to avoid breaking old codes. We want to improve focus while developing. You don't want to bother about breaking things that have been done already. You just want to build, and if you run the test again, you know where your issues are coming from. Okay? So you want to verify if your machine works properly. You know that if your machine, if it's a simple sum and you are having something funny, you know, okay, probably there might be something wrong with your interpreter, or you need to restart something. Okay, it helps you get up to speed. Next thing is documentation. So we write tests sometimes to document, to explain. For example, if you're onboarding a new person onto the team, and you've seen the test. The test has assertions where you say, okay, this code you're expecting this. You shouldn't expect this. You're expecting a sum, but so it helps as a documentation. So anybody that comes and read your test would be well aware that, okay, this is what I expect, and if I'm not getting this, that means it's broken. Okay, so so in testing in Go, we always start the file with a underscore test.go. So you're trying to refer, like for example, we have sum.go and then sum underscore test.go. So what the sum underscore test.go is explaining, is testing what is in sum. It's testing what is in the sum package. Okay. So we know that it was like I explained before, it was basic addition. So what we did here was just write a test for the sum, and running our test command for a basic test command, running a basic test, what we need to, after writing our test, we run the go test command for the output. But we'll talk about that like more as we go on. All right. So we have the go test. These are just some commands. These are some test commands in Go. Like the simple go test, it runs your current package. If you're in a package and you want to run the test on that package, on that root, the root of that package, just run test. You can run test, go test, then some. Like, so when I mean some package, like it could be you want to run a particular test in a package. You don't want to run everything. So you kind of add the directory, okay? You add the directory to where your test is. And we have the verbose, and when we go on, we will see applications where we use this test. So when we're writing tests, what do we really want to focus on? What should really matter to us? So we know that our test will always have the test body and the test report. Okay? We're concerned about our test body and our test report. So obviously it's a code. Even though it's test, it's still a code. So we want to write it as simple as possible. We want to write it as clean as possible. We want to write it as simple as possible. We want to make it reusable. Okay? We want to make our test reusable. For example, if I'm going to test a feature, and I'm going to add for example, I'm going to add like another test under it. I don't want to start writing a full-on test again. I don't want to start writing a full-on test suite. I should be able to just add a new test case to my subsets. But we'll talk about subsets as we go on. So you want it to be very reusable. As well, your test report. So after running your test, what do I see on my terminal? I want my test report to be very readable. I want it to go straight to the point. Okay, this failed, this doesn't fail, this works, this passed. I want my feedback to be able to assist me in debugging. There isn't any point writing tests if I'm not able to debug my code. I want the test to be able to run quickly. I'm not trying to hit my database when I'm running the test. I'm not trying to hit an offline endpoint. I try to mock and make sure that my test runs quickly because I want quick reports and I want to go and debug. So the thing is, why we want tests, we don't want tests to be our, like what we are doing as software developers. We want to build. So test is only like, okay, I want to move forward. Does this work or doesn't it work? I want to move forward, okay? So that's why we write our test reports should run quickly. So like I mentioned, we want it to be clean. So for example, this is an example of an overcomplicated test. So this is the code we're trying to test for, but this is how simple this code is. But this is an example of an overcomplicated test where we say it's even, then we test using a variable we expect 4 is even, we test using a variable and we expect 5 is odd. So it's like you're writing multiple text cases when we can all squash this into a cleaner way, like an array, and we run the test as one single test. Okay? So this is just an example of how having a complicated test could look like. This is not necessary. So what's happening here is that it's repeating the logic. It's harder to extend. For example, if I have to test for 100 variables, you wouldn't be doing this 100 times. Okay? Then it lacks clarity, and then it's difficult to scale. Like I mentioned, if you're trying to add something new, like it will be hard for you to scale going forward, like multiple features. It will be hard for you to test multiple features. So for example, this is what a clean code looks like. So remember, previously, we had the same test for 5, test for 4, test for 100, test for 1,000. But like in this, we call this, I'm going to explain this as we go on forward. This is called table testing, where we arrange our tests in an array and run it all once using the t.run command. So this has more clarity. This is you can extend this. I can easily go to my array and add a new case that I want to test for, and add a new variable I want to test for, and it's easily maintainable. So when my readable test results, for like I mentioned earlier, if when I'm reading my test, I want it to be the output to be very concise and informative, go straight to the point. Where am I having my issues from? I wrote the attestation. Does the attestation point to what exactly is wrong? Then my feedback should be immediate and indicate failure or error, and speed in feedbacks. So, like I mentioned, table tests, table-driven tests. So we saw where you define your inputs, and your expected outputs. So we saw so 4 should be true. You know we're testing for which number is even, right? So 4 should be true, 5 should be false. It's 100,000, I think that's a million, should be true. 999,000 should be false because that's an odd number. So that's what table-driven test is saying. We create an array where we have our inputs and our expected outputs as like in that format, and we easily run like an if statement that just runs like a range in Go that runs through those array and gives you the result of those codes. So you can test multiple arrays, you can test like multiple functions, and it's less repetitive, it's clearer, and you can easily maintain it. So using subtests, for example, if I'm testing, let's say I'm testing for a payment, I'm testing for a payment service. I wouldn't write, like, if I say, like, let's say I have a system, and I have both payment service, I have shop, and I have, let's say, logistics. So I want all my tests for payment to be in one place. Like, I don't want to write multiple tests at several. I don't want to write like what's it called? I don't want to write a logistics test in my payments, and then when I'm trying to debug, I will be going to where like my payment is to look for the logistics. So I want to write subtests so that I want to write it in like writing grouping test cases together. That's what subtesting means. So for example, when you're testing your code, you want things to be related. You want your code to have, like, it should, when I'm writing the test, all my tests should have, okay, did the payment work? I'm testing for if payments work. I'm testing for if I have an error with my payments. I'm testing for if my endpoint is down or should be in a payment. Then I should have like a logistics part, and then I should have a anyhow do you want your code to go? So for example, okay, we're trying to test like if it returns an upper string. So what basically this point I'm trying to show us how the output should look. So let's go forward. So like I mentioned before, like I mentioned, table testing. So we arrange our test. This is the name of the test. Then we have the input, and then we have the expected outputs. So you remember this test is supposed to return variables in upper there. So if it doesn't return the input as an uppercase output, that means it has failed, right? So what is happening here is that we run, like I mentioned, that we run this test in parallel. So we run all lowercase. When we take these inputs, we take the input here, t.name, that's all lowercase. That will be the name of the test. And then it will take in the input to upper. You know, to upper is the name of our code here, right? It's the name of the function. So to upper, what do we take? We take in tc. That means this is tc. When I mean tc, is like the variable, the struct we've made. It takes tc as the input, and then the expected output is tc.expected. Do you understand? We've already created the struct on how it should look. So we run the test. We use t.run. We create a range first. Then we use t.run to run through all these variables to give us an expected output. So you understand how these subtests work now, right? Like, we create a similar test. We create a struct. Then we write like the name of the test, the input, and the output. then we run it in a range so that it goes through the variables. So how do we run the test? Like I mentioned, we have various methods of running tests depending on the details you want from your test. So this is a focus detail. This is a focus test detail where I'm running this test, and this is the output. So when I run test.go, when I run go test, we have, in a situation where all tests pass, we just have okay, because it makes it like a simple detailed, okay, everything passed, I can go forward, I don't have to waste time. In a case where it fails, it tells us exactly where it failed, okay? So what I did is I changed, like what I did before running the code, I changed the hello, I changed it and I removed the exclamation mark, and then what it did was like it returned like, okay, the test upper failed, and it told us where exactly failed, okay? But if I want more detail from this test, if I want more detail from my test, what I'll do is that I will run using verbose method. What verbose method means is just adding the -v flag. So what it does is that it gives you more details of what your test, like the test you just ran. So before I show you an example of what it looks like, verbose method, we always don't want to use it because it clutters our terminal, and especially when you want to run simple tests like the one we just did previously, and then it's hard to see failure at a glance. For example, this one, I was able to just say, okay, I knew what exactly failed. For this one, I knew, okay, everything passed, I just move on. But this one, I knew exactly what failed, I can go and attend to that. But like in the verbose method, you see everything, and you see which passed. It gives you a lot more details, and all I did was just add the -v tag, okay? And in a situation where the same character failed, it gave us, okay, test upper and why it failed, and the ones that failed and the ones that passed, okay? So parallel texting and parallelism in testing. So when we are running multiple tests that are not using the same, resources. For example, if you're running a test on your data, if you want to run like a full-on test, you've created a test suite and you want to run a test that will test your database, that also tests your services, and will also test like some other thing within a small service. What you do is that you want to run it, you want to add the t.parallel tag, because what it does is that it runs all tests concurrently. So I can have a multiple of this and I have at the bottom all running concurrently. Do you feel me? So and then the next thing we want to talk about is writing assertions. So assertions are those, for example, you remembered uppercase, where it showed the details of like, okay, test to upper, and then it showed like, that's an assertion, like, okay, what is broken? Do you understand? Like, it's the text that shows on your terminal when something is broken. So there are different libraries we can use. I'll talk about that at the end. There are different packages we can use that can help us write easier assertions. But if we're writing our assertions ourselves, we want to ensure that those assertions are very descriptive. They're straight to the point, but they're descriptive of the function you're writing, the name of the function you're writing, or whatever broke inside the function. Okay? So we have several test packages in Go. We don't have to write our test from scratch, like I showed you earlier, but we do understand the logic of how these tests work. Okay? But that said, we don't have to write tests from the beginning. So there are several test packages, and that's the first one we have is Testify. So it's a toolkit that helps us easily write assertions. It helps us in mocking, and it has like a testing interface and function. So I would share this slide after our talk so that we can visit the GitHub link, or you can visit the GitHub link and you see like the full package, descriptions and details. So let me show you how Testify is used. So this is from their GitHub. So what you do is you easily just mention assert.equal. So what you're trying to do is you are trying to assert if these two variables that you're taking in, it takes in the testing flag at the beginning. Then it tells you, okay, are these two variables, are they equal? And then this is the assertion, they should be equal. So when you're running your test, if you see an unexpected result, it shows error and tells you that these two variables should be equal. Same thing happens to not equal. they should definitely not be equal. So it tells you they should not be equal. So if somebody imputes 1, 2, 3, and then 1, 2, 3, this test will fail because it's supposed to assert that they are not equal. Do you understand? Then so this is like a simplification of what testify could literally do. We could replace those inputs, those 1, 2, 3, 4, 5, 6, or 1, 2, 3, 1, 2, 3 with whatever input or output we are getting from our functions that we've personally written. Okay? Then so this just goes further to tell us like creating an object. For like in the previous one we ran assets like we just ran assets. For each of them we use the assets package. But we could create an object where we easily use it. Like, for example, if we're going to use like if we're going to be writing a very large number of code, we can easily just use an easy object and then start writing our test. Like if we want to write sub tests, okay. So the next package is GoConvey. GoConvey. What GoConvey help you do is that it shows you behavioral tests. It shows you the UI on your browser. You can see what exactly fails on your test. For example, this is what when you run your GoConvey. Okay, you can follow the GitHub link to see their package. So this is how it shows up on your browser. So it gives you a very detailed representation of what your code is. So this is where you want to do big man things that you want to see. You want to go deeply into why something is failing, the behaviors of like the test, the time it takes to respond, and all of that. So this is what happens when it fails. It tells you the difference and what should be expected, the actual value. It kind of gives you a well-detailed test result, okay? So other mocks. So let me talk about what mocking is basically. So mocking is critical for isolating, when you want to isolate for example, when you want to test, we don't want to test our actual database, but we want to test the function that accesses our actual database, okay? So that's what mocking does. Mocking creates that environment where your function hits your mocked database. And for mocking, also we mock endpoints as well. We want to mock the result that an endpoint could give us. We want to mock how it responds. So we want to let's for example we have a function that hits an endpoint. We don't want to actually hit that endpoint because that endpoint could be down. But we want to see how it responds when maybe the endpoint is having an error or the endpoint is fully functional. Okay? So best practice in mocking, we want to keep it simple. Everything we're doing, we're trying to keep it simple. Because then we're trying to ensure that it covers edge cases. Like I mentioned initially, when we're writing our test, we want to ensure that we've thought through our design and we have edge cases, and our test should be able to pass those edge cases. Okay? So HTTP mock is a library in Go where we used to test HTTP requests. So we can mock our HTTP requests, we can mock our base URL, we can mock our custom response we can mock what an endpoint will return, and then we can use that return to test our functions, okay? But we don't want to hit the function directly that is online. For example, why do we really even want to mock? Because let's say if I'm testing, my colleague that came up to test, what was that, Stripe. You really don't want to hit Stripe for a test and spend $30, to be honest. So what I want to do is I want to test those, like the response that will come out, like the response that Stripe will give us, and we can use that to test our function in the case where it fails or it doesn't. So this is an example of how we mock our API endpoint. So we take in the API, we HTTP mock the register the responder, and we know it's a get response. It's a get request, and where are we trying to get requests? We're trying to get requests from that endpoint, and what are we supposed to expect? We're supposed to expect a 200 response and and that's the object that's supposed to be returned. So we test using this mock, okay? So we also have SQL mock. So this helps us test our database. So also, like I mentioned, you don't want to hit your live database. You want to create an environment that gives your function the same the same effect that it would happen when you hit a database. So like SQL function is a package that helps you achieve that. It helps you mock your database. Either it's non-SQLized or SQLized, and it helps you for basic regular matching. It helps you mock also requests. For example, if you want to do a push request from the so if you want to do like a get request from the database, so a query from the database, it helps you mock those what is expected, and that can help you write better, give better outputs of your code. So the next thing, why do we want to mock? Like I mentioned, we want to isolate our logic. So we don't want to, like I mentioned, we don't want to always hit live resources. We want to isolate our logic. We want to increase speed. So it could take me a while to like get response from my database to test my function, or from my endpoint that could be far away to test my function that could possibly be down as well. So we want to increase speed and just remove those external forces and just test what is working on our code. We want to ensure that it's repeatable. We want to ensure that we pass all edge cases. So what are the best practices? Like I always mention, you don't really want to over mock. You just want to keep it simple. You want to be able to test for multiple scenarios, both when we expect an error or when we get an error. We want to ensure that our test covers that, and when we don't get an error, and also I feel like this is not covered as well a lot when we get an empty response. Because for example, if you hit an endpoint and you get a response, now let's say that response is supposed to receive a message that says, "Okay, I'm fine," but when you hit the endpoint, it didn't get that "Okay, I am fine." It just got an empty string. But that's also a successful message, because it responded with an empty array. So we want to actually test for such cases as well, where we get a successful response, but we don't get something. We don't get like an active, an output from the endpoint. They want to keep mock simple. So I'm going to keep it forward. Like we can visit this is from their database as well. You create this is where we want to get a user ID, and this is what the tests look like. This is how we mock our database. So you create a new SQL mock. You create a mock for the expected query. You add a row, like I did. I added my name. You can use that to test your functions. Okay. So we have Ginkgo. That's another package as well. We can always check that out. So what are the common pitfalls when testing? So we want to avoid overusing mock. We want to keep our test suite fast and efficient. So we want to avoid long tests. We want to keep it simple, okay? Only necessary things should be added to our test. We want to use parallel testing. For example, if we're running a test on a very large code, we don't want to wait forever. We want to keep everything running concurrently. We want to ensure that that our code returns outputs like from various regions concurrently and spends less time. And another thing, we don't want to test trivial codes. I'm sure there's some helper functions on your code base that you really don't want to be testing. So we don't want to waste our time testing trivial codes, getters and setters. So what are the golden rules when testing? So while testing, we don't want to put important essential informations in our tests. Okay? Our test should be simple and straightforward. We also don't want to cache our test, because if you're caching our test, if it's cached and you run the test again, let's say you make an improvement to your code, it gives you the same output. So we want to ensure that our test is not cached. So if you want to reach out to me, you can reach me on LinkedIn, Twitter, or GitHub.